Okay, we're going to talk about the remainder theorem today. If a polynomial p of x is divided by x minus c using synthetic division, the remainder is equal to the polynomial evaluated at c. So let's do a problem with synthetic division. If x minus 2 is the divisor, we put the 0 of that on the outside of our division bar. And then the coefficients of -5, 3, 5, and 2 go on the inside as our dividend. In the synthetic division, we start by dropping the first term, and we multiply and add down the line. So 5 times -2 is -10, add them together is -7, multiply is -14, add is -9, multiply is -18, and the remainder is -16, which says if you actually divide by this factor of x minus 2, the 2 is what you're plugging into the function, would give you an answer of the remainder of -16. So put in polynomial notation, our divisor is x minus 2, multiplied by our quotient of -5x squared minus 7x minus 9, with a remainder of -16. So if we evaluate, it says that when we plug in 2, that answer would be -16. So looking at this function, if you plug in 2 right here, that makes this value equal to 0, which makes 0 times anything equal to 0, which means your answer is now -16, which happens to be the remainder. If you do this longhand by evaluating by plugging in the 2 into our function, plug in 2 every time you see an x into the original equation, and you evaluate each individual term. So 2 cubed is 8, 8 times -5 is -40, 2 squared is 4, 4 times 3 is 12, 5 times 2 is 10, an additional 2. If you add up -40 plus 12 plus 10 plus 2, that will equal -16. The same answer as if you divide by 2 in synthetic division and look at the remainder.